Ultimately, GraphQL is language agnostic, meaning it can be used in almost any programming language, not just JavaScript. So the question that we have in terms of using all these GraphQL operations in our React applications is, how do we do that? How do we perform all of these different operations with React? Well, fortunately, there is a library that was created for just such a purpose called Apollo GraphQL. Apollo brings all the power of GraphQL into React apps, as well as many other JavaScript libraries and frameworks. So if we go to the documentation, you'll see an option here for Apollo Client React, where you can get a brief overview of exactly what Apollo Client does. And ultimately, it gives us a lot of tools and features that make it really easy to use GraphQL, everything that we'd want from GraphQL right within React. And that means it allows us to take advantage of the latest React features, such as hooks that are custom made to let us run any query, mutation, or subscription that we want. So to get started with Apollo Client, we can just go to the Get Started link. And if we scroll down, you'll see that there's a number of dependencies that we need. A few of them come from Apollo, such as Apollo Boost and Apollo React hooks. Apollo Boost gives us the tools to set up Apollo Client within our React app, and hooks gives us the ability to run any GraphQL operation we like. But we also need to install GraphQL to enable us to parse our GraphQL queries. But of course, to install each of these dependencies, we're going to need to have a React application to work with. So once again, let's open up our terminal and create a new React app. I'll do so on my desktop. And once again, we'll run npx create React app, and I'm going to call my app GraphQL checklist. And once that's done, let's cd into our app folder, GraphQL checklist. And before we actually open this in VS Code, I'd recommend installing all these packages right here. You can just copy this line if you see it. Otherwise, install Apollo Boost at Apollo/React hooks and GraphQL. And we'll let that run. And once all of those packages have been installed, let's open up our project folder in our code editor. And once again, let's clean our source folder out a bit. We're going to build our entire to-do application within our app.js file. So we want to leave app.js and index.js, but everything else can go. And we also, within app.js, want to remove unnecessary imports, replace all of the returned JSX with just a simple div with the text app for now. And then within index.js, we'll remove everything except for the React import, React DOM import, app import, and then render our application. And to make sure everything's working, we'll run npm start and make sure it starts up on localhost 3000. Now, what do we want our to-do application to do? Well, we want it to be able to add to-dos, to toggle to-dos, to toggle to-dos done, to delete to-dos, and obviously to list all of our to-dos and display any updates to our user when we execute any mutation. So I believe the easiest task is to list our to-dos, since we already have some to work with. So first, to use Apollo, we have to configure it. I'd recommend doing so in index.js, and this is going to consist of setting up our client by instantiating a new client. So we'll need to import Apollo client from the Apollo Boost package to do so. So our client is going to keep track of all of our settings. It's going to keep track of what endpoint we're going to be making requests to, and it's going to be creating something very important called our cache, which we'll touch on in a bit. But right now, from our Hasura console, we want to grab up at the top of the graphical tab, our GraphQL endpoint. We want to grab this entire URL, and to instantiate our client, we say new Apollo client, and within an object, we just have to pass in one property called the URI. So we just need to provide the URI or the endpoint that we'll be making requests to. And then we're going to get back our client. Now this is the core part of Apollo, and we can do everything with our client. So let's get started right now by seeing how to execute our to-dos query. We'll take a step back in our history. We'll execute get to-dos, which we know works. And to do that, all we have to do is say client.query. There's a whole lot of methods that it has on it. And then within an object, we provide a query property, which is going to be a special string. Now, we can't write our queries just like this, as we did within the Graphical Explorer. We have to parse our queries. We're writing it within a JavaScript file, so we need a special tool that's going to be able to pass along the information needed to make the query. And for that, we're going to need to also get from Apollo Boost. We'll add a comma in our import statement, and between curly braces, grab the tool GQL. GQL is a function that uses tag template literals. So we use a couple of backticks between which we pass our query that we want to execute. We say GQL, then these two backticks, and then we pass in the query we want to be performed. So we can copy the get to dos query and paste it in here. And now this is a string that our client can make sense of. And by default, Apollo client is going to perform this with an HTTP request. And this is going to be executed as a promise. You can see here it returns a promise. So to resolve it, to get the returned data, all of our JSON data back, we can just chain on a then callback. We can get our data, and for now we can just console log it. So now when we save everything and check out our app, check out the console. We see this object within which a bunch of stuff is provided, data, loading, network status. But this data object looks familiar, and within it we have a to-dos array and our two to-dos within that table. So this is Apollo in a nutshell. We have a client, which was very easy to create, and now we want to pass this client throughout our entire application. So how do we do that? How do we pass data throughout our entire component tree? Well, we can use React Context, and that's exactly what Apollo Client does. So we can remove this or comment this out. We can remove the GQL import, and we're going to import now Apollo Provider from the @Apollo/React Hooks package. Now, all we have to do to pass our client throughout our entire app is just wrap it with Apollo Provider with that component, and it has a special prop just for the client, so we can set client equal to our instantiated client. So that's it. That's the entire process of setting up Apollo. And make a note of the fact that Apollo client is a default import, not imported between curly braces, but Apollo Provider is. This is a common source of errors when setting Apollo up. So now within our app component, we want to display our array of to-dos on the page. And instead of using the client directly like this, we can within our function components use the set of hooks, special hooks that Apollo React Hooks makes available to us. So let's flip over to app.js and let's import up at the top our first hook, use query from Apollo React Hooks. And like all hooks, it must be executed up at the top of the component. So we'll call it use query. And once again, we need to write out our query with the help of GQL. So we'll import GQL from Apollo Boost. This is the pattern we'll be using for basically every function component that we write. We import a hook to perform a given GraphQL operation, and we also import GQL to parse our query itself. So first we need to write our query, and most commonly we write it within a variable. So let's write this out once again, GQL, and then paste in get to-dos, and we want to put this in a variable of the same name, but since this isn't going to change, we can use the convention of making our const variable name uppercase, all uppercase, and then separating any words by underscores, so that we know that this variable value is never going to be updated in any way. So now we can pass get to-dos to use query. That's the only thing that it requires. And what do we get back? Well, we don't have to resolve this like a promise. We can just call it like this, like a synchronous function, and we get back a bunch of stuff, what I'm going to call stuff at the moment. I'm just going to console log that. So once we save, instead of just seeing one object, we see two here with different things in it. So if I open the first one, you see a lot of information here, but note that data is undefined for the first object, but for the second one, data actually has an object. So for the first log, we see that the property loading is set to true, and then after a short period of time, loading is set to false. So naturally, what matters to us is the data, but at first it's going to be undefined, and that's when loading is true. So since we're getting back an object in either case, we can just destructure stuff and get those two properties. We care about data and loading. So if loading is true, then we can just return, say, a div with the text loading. We can't do anything with the data yet. But when we have our data, we can take the data, then the to-dos property, and then map over it. So within our return JSX, we can say data.todos.map for each to-do. Let's put it within a paragraph element where the key is set to to-do.id. Then the text is going to be within a span from to-do.text. And then underneath the span we'll have, or I should say to the right hand side of the span, we'll have a button where we'll have a Unicode X. So we can click on that X to delete our to-do if we want. So let's save, see what we get. We briefly see loading, and then we see our two to-dos. Now, another question worth asking is, what if there's a problem in performing this query and loading our to-dos? There could be a network error, or what if we wrote one of our queries incorrectly? We don't have IntelliSense here to tell us about that error, so what if I made a spelling error for one of the subfields? I hit save. What's going to happen? Well, our entire app is going to crash. It can't read property to-dos of undefined. We're trying to map over an array that doesn't exist because we never get our data. So how can we prevent that? Well, in addition to the properties data and loading, we also get back from the object that useQuery returns from our query. If it's not resolved properly, we're going to get a value on this data property. So we can also check for that. We can say if error, if there's an error, we want to return the fact that there was one. We want to tell our user about it, so we can say error fetching to-dos. So we might have here loading to-dos, and then if there's an error fetching to-dos. So if we save that, now we see the problem in our UI. The user clearly sees it, and we also get a cleaner error in our console. So we just need to fix that typo. So we've got Apollo set up. We've executed our first query. We know how to handle loading and error states. But let's build out the rest of the static structure of our application. As we mentioned, we want to not only list to-dos, but add them. So we need an input, a form to be able to do so. We want to toggle them, and we want to delete them. So we want to create a nicer looking user interface than this, as well as all of the elements that we have to add. So let's begin by adding the HTML that we need. So first of all, we'll give it a title. We'll give it an H1 up at the top. It says GraphQL checklist. And then underneath that, we'll have our to-do form. So we'll have a form element and an input within it where the type will be text. The placeholder will be write your to-do, and then we'll have a button to the right hand side of it that says create with the type of submit. Then underneath the form, we'll have our to-do list. And now let's put all of our to-dos that we're iterating over, we'll put that within a parent div. And that'll be it. So let's save and take a look at what we have. So we have our complete structure, but the appearance leaves a lot to be desired. So let's add a CSS library that's going to make styling this a lot easier. We could add our own styles that we create manually, but one CSS library that I like to use that gives us a lot of utility classes to be able to just add the classes that we need directly on our elements without having to create the styles ourselves is one called Tachyons. So to bring in Tachyons, we can just head to tachyons.io, and we're going to bring in the library through the CDN link. So in the Getting Started area, let's copy this link right up here that references a CDN to the Tachyon CSS file, and let's head into our public folder once that's copied and go into index.html and paste that in anywhere within our head, our document head, and then we can save and start adding classes. So again, this library works just by adding classes that can be chained on. We can chain on as many classes as we need to get the styles that we want. And you can see a lot of information about what these classes do by looking at the documentation. So if you go to any section, say you want to see how to style links, you can go to the links section, and you can be given a lot of ideas about how to modify styles by just adding these different utility classes, as they're called. So if we wanted to do something that would usually require a lot of CSS, say add a background color when you hover over a link, all you'd have to do is for that link, add the class link. You can give it the color black with the black class. You can give it the class hover BG light blue, so that when you hover over it, you get a light blue background. And there's really a lot that you can do with it. You can even add classes that give you nice transitions, such as this one. But instead of going through the documentation, I just want to show you visually. So I'll just bring my page to the side here. And for the parent div that we're returning, we'll give it the classes VH100 to cover the entire height of the page. We'll give everything a code font. And then we'll center everything with Flexbox. We'll use the classes flex, flex-column, items-center, and then we'll set the background to purple with BG purple. We'll make all the text white, the white class. We'll give this div some padding with PA3. 3 is just a variant of PA, and we can set this to, I believe, 1 through 5. So we can increase the number of padding if we set it to, say, PA4, and then FL1. And we'll give the H1 the class F2L. Then I just want to add a little emoji to the right-hand side of the title. So to do that, I'll add a span, the role image with an ARIA label. For screen readers, that includes the text checkmark, so we're including a checkmark image here, a checkmark emoji here. We'll just insert that. I'll just add a space. Then on the form itself, I'll give it a class name of MB3 or margin bottom 3 to separate it from the list. And for the input, I'll give it padding of 2, font size 4, then a border that's dashed with B dash dash dashed. Then for the button, it'll have classes PA2, F4 as well, and then BG green. And then for the list, for its div, I'll give it the classes flex items center, justify center, and flex column. Again, we want to center all of our to-dos within our list. For the span that wraps around our to-do text, we'll give it the classes pointer to give it a cursor of pointer, list, PA1, and F3. And then for the button, we'll make the button transparent with BG transparent. We'll give it some button styles with BN and font size 4 with F4. Then to make the X red, we can wrap it with a span and give it the class name red. So now we have a completely styled app, more presentable application that was created just by chaining together these different classes that Tachyon makes available to us. So now that we've styled our app, let's take a look at how we can execute our first mutation. We've seen how to execute our first query with the use query hook, but now let's say we want to see how to toggle our to-dos. And the functionality that we're going to want to have within our app is that when a user double clicks on the to-do, they toggle it where done is set to true if it wasn't before, and when done is true, we put a strike through the entire to-do item to indicate that it's been completed. And if it's been completed but then double click on it again, done is set to false, and we remove the strike through. So first the question is, how are we going to execute a mutation within our app component? Well, just as we have the use query hook, we can also grab from Apollo React hooks, use mutation. And we know that we can use multiple hooks within a single component, so we can execute it right underneath where we called use query. Now, what I'd recommend before executing or writing out any query or mutation or subscription within your React app is to first write it out and execute it within your Hasura console, your GraphQL console. So let's head back there and see how we would toggle our to-do. We might already have it written out, but let's just start from scratch. We'll clear out our Explorer and we want to add a new mutation, and we want to, in toggling our to-do, update it to-do. So we'll use update to-dos, and we can call this mutation, we can get rid of the type name field, we can call this mutation toggle to-do. So how do we execute this? Well, we want to find the to-do where the ID is what we clicked on. So what we'll soon see how to do is we'll see how to pass the ID of the to-do that a user clicks and provide it to our mutation. But for right now, let's just hard code the values. So we want to find the to-do where the ID is one of our to-dos, so we can just select the one that we last updated. So we'll find it where the ID is equal to, using the underscore EQ operator, is equal to, say, this ID. You can grab any to-dos ID within your to-dos table. So we'll select that ID, and we want to set the opposite value for done. So for this to-do that I'm updating, currently it has the field done set to true. When we toggle our to-do, we want to set it to the opposite Boolean value. So we want to set done to false here. Now to select our returning rows, we can grab done, ID, and text. Now before we execute this, we need to think about how it's going to be executed within our client. Remember what we said regarding the fact that dynamic values needed to be passed to our mutations or queries that accepted any arguments within our React application, because those values would be different between executions. So we need to create some variables for both ID to hold both the ID value and the done value. So to do that, we'll add another set of parentheses after toggle to do. We want to declare our variables. We'll call the first one ID with $ID, and it's going to have a type of UUID and required. Then we'll add a comma and then add the type for done, which is Boolean. So $done is going to be a Boolean and required. So within query variables, let's add an object and add values to both ID. So we can copy that value and replace it with our ID variable, assign the ID value to that variable, and then take the Boolean value for done, pass in the variable done, and assign done a value of false. So now when we execute this, we see done is set to false for that particular to-do. So we see that this works. We always want to go through this process of making sure our query or mutation or subscription works in graphical before we actually try performing that operation in our client. It's going to help us reduce the number of errors that we run into. So again, we want to create a variable that's going to hold on to this mutation so we can execute it. So we'll call this variable that'll hold it toggle to do, set to GQL, and then we can paste in mutation, the successful mutation that we wrote here, and we'll pass toggle to do to use mutation. Now as compared to getting back from use query data loading error, data loading and error among other values, what we're going to get back from use mutation that's going to be most important is a function. But instead of getting it back within an object, we're going to get it back as the first element in an array. So here we want to use array destructuring, and we're going to call this function toggle to do in camel case. Now we want to execute this mutation whenever we double click on a to do. So we're going to add to the paragraph element on double click, that'll be the event, and it's going to be handled by a new function. We'll call this handle toggle to do, and we'll create that above our return. So we'll create that function, and naturally we want to execute toggle to do itself. But to execute it, we need to pass through the two values it needs, the ID of the to-do we want to toggle, as well as the appropriate value for done, for its done property. So let's head back down, and instead of passing handle toggle to do as a reference, we'll use an inline arrow function and call handle toggle to do in the return, and we want to pass through the entire to do object. So that ensures we just get a particular to do, we pass through all of its data all the way up to the function itself. So we're going to get a to do here, the to do that was clicked on twice. And to pass through these two values to our mutation, we can add an object when we're calling the mutation function, and those values are going to be provided on a variables object. And we just need to look at our mutation itself to see what properties it should accept. It should accept an ID property with the appropriate value and a done property with the appropriate value. So here we'll set ID to do.id, and done will be set to not todo.done, but the opposite value. We want to change it to the opposite Boolean value. And if we want to make our code even more concise, we can just destructure the properties ID and done within the parameters of handle toggle to do So we can now reduce our variables object to just ID, the property and value, and done to the opposite Boolean value. And as for the mutation function toggle to do, though we can execute it like this synchronously, it returns a promise. So to resolve it and get back to do data, this returning subfield and all of the updated to do data, we can either chain on a then callback and then get the data like this, or we could write this as an async function, so we could prepend the function keyword with async and just await toggle to do. We can wait for that promise to be resolved and then put the return data in its own variable and say console log it. And then for the final step, when a user double clicks on a given to do, let me just save this. When a user double clicks on a given to do, we want to strike through that to do if it's done. So on our paragraph element, or rather on our span, which holds our text, we can just add a simple conditional using template literals. And we can say if todo.done is true, then we want to add the class and add the class strike, which gives it a strike through. So now let's save app and test this out. We see immediately take out the trash is struck through, and if we double click it, now it's no longer done. If we double click pay bills, now it is done. And if we take a look at our console, we get back an object with the properties data, within an update to do's, then in returning, we see done for that to do is first true, and then if we double tap, now that value is false. So note that we didn't have to do any local state manipulation. It seemed that Apollo just knew that what we wanted to do. We wanted to update it to do, and then our UI immediately responded. We'll look into why exactly that's the case in just a bit. Now we're going to cover the next mutation, the next feature we want to add to our app, which is adding to-dos. So we want to make this form useful. So now we're going to need to revisit how we're going to add a to-do. We can look back in our history and take a look at add to-do. We saw that it just required one argument, the text argument, but we want to rewrite this to make the text value dynamic. So once again, we want to declare the appropriate variables, in this case just one variable, text, and this was of type string and required. So within our query variables panel, we'll set our newly declared variable text to some new text value and pass in our variable to where we're executing insert to-dos. And let's say for our new to-do, we want to have that be, say, mail letter. And now let's execute this mutation. We see our new to-do was added, so we see that this works. So once again, let's execute the use mutation hook. We need to create a new variable called, say, add to do. We'll pass in mutation that we wrote to GQL, pass add to do to use mutation, and we're going to get back our mutation function, our mutate function, which will give the same name, add to do. And here we want to create a new to do when our form's submitted. So we want to add an on submit. So when we have a submit event, we will execute a function handle submit. We could also call this handle add to do to be more precise. We'll create this function underneath handle toggle to do. And first, up at the top, we want to receive the event and call event.preventDefault to prevent the page from refreshing. But once again, for our mutation, we are going to need to provide some data on this variables object. We need to get some text, so we need to store the text that's being written into the input, and we can do that with an onChange. So we're kind of working backwards here, but we want to create some dedicated state for this text to live in. So let's call react.useState. We'll make this initially an empty string, and let's call this state variable toDoText. We want to store this toDoText when we call setToDoText. So when we get an event from the onChange, we can just write an inline function and call setToDoText and pass in event.target.value. And we also want to make this a controlled component, so we'll set the input's value to toDoText so that it's controlled by state, so that we can easily clear this out. So now that we're updating toDoText, we have something to pass to our addToDo function. First, however, I'd recommend that we actually have something typed into our form. We don't want it to be possible for a user to just type a bunch of white space and submit a new to-do. So we first want to check and make sure it's not empty. So we'll say if not toDoText. If there's no toDoText, then we just want to return. And we can make sure that it's not empty by using the trim method on the text that we get. We can trim off any white space, make sure that there's no white space there, and only in that case do we want to call addToDo, and for its variables we want to provide on the variables object text. We need to provide the text value, and that's going to come from toDoText. Once again, it would make sense to get the data back if the mutation's executed successfully, and then we want to await addToDo. We can get back our data again and console log it. So for our first console log within handle toggle toDo, we could give it some text. To differentiate it in the console, we could say toggled toDo here, and for added toDo, we could say added toDo. And finally, at the very end, we want to clear out the text within the input, within the form. So we'll call setToDoText and set that back to an empty string. So this is a pretty straightforward process. If I didn't make any mistakes, we should be able to save app. And I'll try adding a new toDo and hit create. And what's interesting is that the form was cleared out. We have a new log in our console, added toDo, and we indeed get our data with the appropriate text and new ID, but there's no new toDo displayed within the UI. We have to refresh in order to see that. So what's strange is that the first mutation that we executed, where we toggled the toDo, that immediately updated the UI, but adding a new toDo didn't. Why is that the case? Well, this leads us to discussing a little bit more about what Apollo is doing when it sets up a new client. By default, when Apollo creates a new client, or rather when we create a client, Apollo has an internal cache. We can think of this as kind of an internal record of our data. In some cases, when we execute a mutation, like the toggle toDo mutation, it's easy for Apollo to use that cache to update our UI. For mutations, when we're just updating a given resource, as we are here where we're just toggling done to its opposite value, Apollo can often take care of figuring out how to update the cache appropriately, and therefore how to update the UI. It just seems to magically take place behind the scenes. But for other mutations, such as mutations where we create a new resource, Apollo isn't able to, on its own, update the cache so that we see a new item in our list. It needs some additional instructions to do so. So in more simple terms, for some mutations such as update mutations, Apollo can use its internal cache to say, hey, I see that you're just updating this individual item that's part of this query, get toDos. I know how to update the cache and therefore show the changes in the UI, show the changes to the user. But if you want to add a new item, you're going to need to tell me more information. You're going to need to tell me information about how to update the cache so I can figure out what to display to the user. But right now I'm going to show you an easier approach to be able to update what the user sees, and that involves refetching our original query. Using our mutate function, add to do here, we can add another property after variables called refetch queries. And this is an array. It accepts an array of queries that are each listed within their own object. This basically says, hey, after performing this function, I want you to refetch to re-execute this query that I provide here. So for our case, we want our only query to be get to dos. So we'll pass in our get to dos variable here, and if this query required any variables itself, we would add another property of variables, that variables object. But fortunately, it doesn't require any. So now when we save and we write another to-do, we create it, we immediately refetch the query after performing the mutation, so that created to-do immediately shows up to our user. So this is a tempting approach to want to do, to always refetch a query, and that is because it's so easy to just list all the queries we need to be refetched right here. But in doing this, we're making another request. We're making another HTTP request. So this is something we can do, but it can take more time and use more resources, more computing resources than is really required. So now, before we move on to deleting to-dos, I want to show you one more feature of the use mutation hook, and that is we can actually run some code when our mutation is completed. So similar to refetch queries, where we can execute a query after our mutation's done, we can also run code when a given mutation is completed by adding a second argument to use mutation. We can just add a comma and then an object. And here's where we get access to a onCompleted callback. So instead of clearing our form, clearing our input by calling setToDoText here at the very end of handle add to do, we could comment this out and write an inline arrow function to execute the very same code at the end. So now when we save this and try adding a third to do, note that when we hit create, our form's cleared out just like it was before. And lastly, let's move on to deleting to-dos when a user clicks on this delete button next to a given item. So if we look back at our Explorer, if we select Explorer here, let's choose Add New Mutation, and then choose Delete To-Dos. Let's delete a given to-do, it can be any one, where we're deleting it based off of the ID. So where ID is equal to a certain value. Once again, we can hard code that. And that's really all we need, along with providing some return fields. Note that I'm providing all of the fields here for basically every mutation, although it's not necessary to do so. At this point, for all of our mutations, we're not really using the data that comes back, but I just want you to see all of the data to be clear what we're working with and what's being updated. So let's call this mutation delete to do, and we want to create a variable for our ID value that we'll pass to it. So ID, this variable is going to have a type of UUID, and required, pass ID into our operator, and then for query variables, we'll set ID to the value that we previously had hard-coded. And let's try executing this when everything looks good. And it looks like that was successful. So let's call use mutation once again, create a variable delete to do, pass in what we wrote to GQL, pass delete to do into use mutation, get back our mutate function, and we want to call this function for a given to do whenever a user clicks on the X button. So we'll add a simple on click to that button, and looking ahead to our mutation, we know it accepts an ID, so we'll attach an inline arrow function to on click, and in the return call handle, well, we haven't created a function yet, but we'll call it handle delete to do. Now we could pass through just the ID from todo.id, or we could also pass through the entire to-do object. That's what I'll do. And then we're only going to need the ID property so we can destructure what we need. Then we can call in the function delete to do for its variables object. It's going to just receive the ID as the property name and value. But before a user deletes a given to do, say they accidentally click on the delete button, we want to provide a little confirm pop-up. We want to confirm that they're interested in deleting it. So we'll use window.confirm and provide the text, do you want to delete this to do? And if they do, if the return value that comes back is true, and we'll put it in a variable called isConfirmed, and we'll say if isConfirmed. If the user confirmed it, then we want to actually delete it. Only in that case will we await delete to do. Again, we'll make this an async function. We'll get back our data for when a to-do is deleted. And it looks like we have everything here to successfully execute this mutation. So let's save app.js, and we'll try deleting this third to-do. We'll get our confirm pop-up, do you want to delete this to-do? We hit OK, and we see in the console deleted to-do with the appropriate data, with the text third to-do. But once again, we have to refresh in order to see the changes in our UI. So we saw refetch queries was the easy option, but we made another HTTP request for every query that we're refetching. Instead, it would be better to just update the internal cache and say, hey, I deleted a to-do. I want to tell the cache that Apollo's managing. I want to tell it that we've successfully removed a to-do, and I want to write those changes directly to the get to-dos query to update the UI. So how do we do that? This seems like a complex process. But just like refetch queries, which is another property available within the mutate function, we can add a comma and use the update function. We get access to the update function, and that gives us direct access to the cache. So we can write an inline arrow function here, where in the parameters we get the cache itself. So first we say, hey, give me what's in the cache for get to-dos. What was the previous data for it? So we can create a variable called previous data, and we can read from the cache. We can get what Apollo's storing for that query by calling cache.readQuery. And we can specify that the query that we want to get the data for, the local data for, is get to-dos. This is all the data before the mutation is performed. So once we have what's stored in the cache, we want to manually update it. We want to say, we've deleted a to-do, our data's changed, so we want to take that previous data, specifically the to-dos array, off of it. This has the exact same structure as data up here. Data is just an object that consists of a to-dos property, a to-dos array. So the previous data.todos, we want to filter through this array and make sure every to-do that its ID is not equal to the ID for the one that we deleted. What this will do is remove the to-do that we deleted. So we're going to store the result, that new array, that updated array, in a variable called new to-dos. And all we have to do now, we read from the cache, we manually update it, and then we write back to it. We give our query, we give Apollo the new value to update what the user sees. So the opposite of read query is write query. We say cache.write query. We select the query get to-dos, but we also need to pass through the data itself. That's why we have a data property here, which is going to be an object where specifically we want to update the to-dos array on it with new to-dos. So let's take a look at the result. We'll save app.js and let's delete another to-do. We'll hit the delete button. Do we want to delete this to-do? Okay. Immediately that to-do is gone. We see in our console deleted to-do, and if we refresh, indeed those changes are persisted. So don't be daunted by this idea of the cache with Apollo. It may seem complicated what we're doing when we want to directly update the cache, but it really just consists of this. We read from the cache for a given query. When a mutation's taken place that the cache won't know about, we want to manually update it, update that data, and then write back to that query. And this is going to make a lot more sense to you if you make use of the Apollo dev tools. So be aware that just like with the React dev tools that we have, you can also install, if you're using Google Chrome or Firefox, you can install Apollo dev tools where you can directly look at the cache. So if you just go up to Window, Extensions, and then search for Apollo dev tools, well, you have to go to the web store first, so you'll hit the hamburger button, go to Open Chrome Web Store at the bottom, search for Apollo dev tools, and then you'll want to download the Apollo Client Developer Tools. Add that to Chrome. Once it's been added, you might need to refresh your page. Once you hit the arrow, you'll be able to select the Apollo option here, and you can look at this in addition to having graphical directly within the browser, which is pretty neat. You can also look directly at your cache and get a sense of what Apollo is keeping track of. And now with all that, we have a complete CRUD application, our own GraphQL checklist, where we can add to-dos, we can update them, read them of course, and delete them.